Welcome back, learners. We know we were discussing about the options that is assign in the ETABS, right? So in the assign also, so we have discussed about the joint, we have discussed about the frame, and we have discussed about the shelf. Now, before I explain you about the link and tendon, so let me explain you in detail about the loads. Okay, now when it comes to the loads, so we have three loads applicable here: joint loads, frame loads, and shell loads. So let us discuss today about the shell loads, then we will move to the frame loads, and then we will move to the joint loads. Now when I say shell loads, as the name itself indicate, the shell loads means we are going to apply the load on the slab. Okay, so when the load is going to be applied on the slab, then we call such a load as the shell load. Now when it comes to the shell load, you can see that again there are different types. So the first one, let us see that uniform load set. Okay, you can see what is that uniform load set. So if you see this modify, so you can, it will ask you, right? So you want to have, you can make a set of loads whatever you want. Okay, like for example, you can give the name, and based on the load pattern that what you have selected, okay, you can see dead. Okay, then you can see that you can add live. Okay, so when you have defined the earthquake along x and y direction, that can also be added, or when you have defined about the wind load, that can also be added. So like that you can have your own set of loads on the shell. Okay, so that is one way. The another way is, now say for example, let us consider this slab. I have chosen this slab. Okay, now let me go to assign and let me go to the shell loads. In that uniform load sets we have seen, let us go to uniform. As the name itself indicate, uniform means here the distribution of the loading on the member, that is on the slab, is going to be uniform over its entire length or over its entire width. Okay, so over its entire length or over its entire width. Okay, over its entire length or over its entire width. Okay, over its entire length or over its entire width. Okay, over its entire length or over its entire width, the application of the loading will be uniform. Okay, the application of the loading will be uniform. Okay, the application of the loading will be uniform. Right, the application of the loading will be uniform. So that's why we go for this uniform. Now since we have defined only the dead and live, so here we can have only the two options. You can see the dead and live. Okay, so now let me choose the dead now. Okay, let me choose the dead. Now you can see that there are three options here: replace the existing load, add to the existing load, delete the existing load. Now first let us go to the replace the existing load. Let us assume that no load is applied. Now you want to apply a load of 3 lb per feet square. Okay, I have applied the value as 3, and you know the direction. Direction means in which direction you want. Either you want it along the gravity. Gravity means it is acting along y, or if you want, you can make the load to be applied on x, or you can make the load to be applied on y. And similarly, if you have any other axis, you can give that axis. Usually this will be given as gravity only. Now when I apply, you can see here that this 3 kilonewton will be shown here. Okay, this 3 kilonewton will be shown here. That means the 3 kilonewton per square feet. That means for every square feet, the 3 kilonewton has been applied. That is what the meaning. That's why we call this as uniform load. Okay, that's why we call this as uniform. Okay, so now that is, now in case for this 3 kilonewton, afterwards you came to know that I have to add some additional load here. That means of around 1.5 kilonewton I wanted to add. Then under this only it will be dead. Now I'll put the value as 1.5. Okay, I'll put the value as 1.5. Now you can see that if I click on the replace the existing load, then if I give apply, then this 3 kilonewton will be vanished and that new 1.5 kilonewton will be applied. Okay, here it is showing no object is selected. Okay, now object is selected, 1.5 apply, that 3 kilonewton will be vanished and this new 1.5 kilonewton will be added if I choose replace the existing load. In case already 3 is there, now you wanted to add 1.5 to this, then make it as 1.5. Now instead of replace the existing load, go to add to the existing load, you apply, then it becomes 4.5. 3 plus 1.5, it becomes 4.5. okay, 3 plus 1.5, it becomes 4.5. that is what the difference between add to the existing load and the replace the existing load. Okay, add to the existing load and replace the existing. If you want to delete everything, then just click on this, then delete the existing load, you apply, everything will be deleted. Okay, everything will be deleted. Okay, yes, so that is about this. Now let us assume that I have applied a dead load of 3 lb per square feet I have applied. Now whatever the loads you applied, all the loads you applied will be under dead now. Now if you want to make it as live, you can see that now from dead you choose live and give the value of 2, apply. Now on this slab the 2 loads will be applied. So one will be the dead load of 3 kilonewton per meter square, 3 lb per square feet. Another one will be the live load of 2 lb per square feet. How you can see that? You can see that I can go to display. Okay, so I can go to display, and in that you can see that there is load assigns, and the load that whatever I have assigned is on the shell. And in that if you choose dead and if you give apply, you can see that 3 will come. If you choose live and if you give apply, then you can see 2 will come. Like this you can see. Now in the same manner, when I go to the shell load, this is all about uniform. When I go to non-uniform, you can see that non-uniform represents your load for square feet will not be maintained same. It is going to vary. Okay, so in that let us choose the first, let us give as dead only. Okay, again the direction I will give you gravity only, no change. Okay, now again these 3 options you have already learnt: add to the existing load, replace the existing load, delete the existing load. You know what is the meaning. But now non-uniform load, if you see here, load at point x, y, z, you can see ax plus by plus cz plus d, where x, y, z are the global coordinates, right? So let us give that the 3, it will be 2, it will be 1, and this will be 1. Okay, I have not chosen, so I have chosen. Now I am going to give apply. You can see now 3, 2, 1, 8. That means this is how it is going to vary. Okay, you can make this as 2 again. Okay, you can choose, you can make this as 2, you can give apply. Now it is 3 is to 2 is to 1 is to 2. Okay, 3 is to 2 is to 1 is to 2, right? So you can see again you have an option, use all the values. Okay, that means if I choose means whatever I give here, all the values will be chosen, right? Then you have another option, 0 negative values. Okay, like for example, now when I am choosing, you can see I can give this as minus, I can use this as minus, and if I give apply, you can see that 3 minus 2, 1 minus 2, it is taken. If I use 0 negative values only, okay, then you can see that only the negative values will be considered, minus 2 and minus 2. If you choose this positive values, you can see only the positive values will be considered. Okay, you can see this. Okay, this is how it is. Use all the values means, okay, all the values will be considered. Okay, yes. So this is about the variation in the form of non-uniform loading. The same procedure with respect to the replace the existing load and the delete the existing load will be same. Okay, that is what you can have about uniform load sets, uniform and non-uniform. And the next one is the temperature. So this is the temperature load. Okay, so this is the temperature load, right? So uniform temperature change you can give at what degree. Okay, like for example, if I choose this, I can give 5. So okay, 5 is the uniform temperature. Okay, you can see that you can include the effect of joint temperature, or if you don't want, no, if you apply, so then you can see 5 5 5 it will be considered at entire joints, and the effect of temperature will be considered. Okay, if you include this, so then that will be included. Okay, so similarly live also you can give 3 like this, so that is also possible. Okay, so this is about the applications of the loads on the slab for the dead end line. So let us see the application of the load on the frames in the next video. Thank you, learners.